Okay, so some characteristics about the quadratic graph. As we say, they will always be U-shaped. We refer to these as parabolas. Parabolas. The highest or lowest point of a parabola is its vertex. It was the same exact thing when we talked about absolute value. And there are also some other similarities with absolute values. We'll talk through this lesson and the lesson after we get back from break. Okay, you can fold the parabola along a vertical line passing through a vertex so that the two sides match equally. This property is called reflectional symmetry. Okay, I'm just going to scroll down to some graphs that we have here. We'll go over these in later, but you can see right here, this vertical line right here that I'm drawing right in, this would be the axis of symmetry. If I folded along this line, this piece of the graph would match just on top of this piece of the graph. Same thing over here with this picture. Whoa. If I drew in this axis of symmetry and I folded over, this side would match on this side. Okay, so that's reflectional symmetry. That vertical line that I just drew in is called the axis of symmetry. Okay, if A is positive, we'll say that the parabola opens up, so that would look like a U. If A is negative, we say the parabola opens down. The y-intercept is 0, c. This really plays into a lot of real-life problems when you need to look for a y-intercept, but that's just in general, 0, comma, whatever that c value in ax squared plus bx plus c, 0, c will always be our y-intercept. So here we go. Here are two examples where it says identify the vertex and tell whether it's a maximum or a minimum. Okay, so the vertex is always where the curve changes. You can see here, this is it. If you're moving the curve left to right, following the pencil, going down, now it's turning and going up. So this is where it changes directions. So this is our vertex, okay? Because in this one, it's the lowest point on the graph. The lowest point, we say it's a minimum. So the vertex would be 1, -3, and that's a minimum. In the second graph, okay, right here, watch it once again. We look at a graph moving left to right. So following my pencil, the graph's moving up, it's moving up, it's moving up. I hit this point and now it's going down. Okay, so this top of the point, this is the top of the hill, so we will call this a maximum. That vertex is 1, 5. If we're paying attention to some of the curves that they're showing in the news right now, for the coronavirus, we're hoping to flatten this curve, is what they're saying. Instead of having a big spike, they're trying to make this a lower curve, flattening the curve. So it's actually something that we're talking about a little bit now in real life, looking at these kind of curves.